ages of the garden state. And today we have very special presentations by exceptional young people from elementary school to high school. And we are very excited. And today's host is Miss Donna, and Donna will take over from me. Thank you.
This is really excited. I'm really excited, and I think this is a great opportunity for all of you to see each other present. I know that we are really looking forward to your presentations, and I think it'll be a terrific event. So I just wanted to give you some information in the beginning. First, I guess it would be a good idea, as I see we're all muted except for the speakers. Remember that this is not a competition, okay? It's just a place to share all of our excitement for STEM. You'll have 10 minutes to present, and then you'll have 2 minutes for questions. So at the end of 8 minutes, I'm going to sneak in and say, you have 2 minutes left, okay? So you have to finish up within those 2 minutes. Then we'll have 2 minutes for questions, and then we'll move on to the next presenter. I'll let you know, as I said, with a 2-minute warning. And you presenters will present your slides, and you will control advancing those slides and so forth. So, are we ready? I know this is fun. I'm really excited and looking forward to this. So tonight, what we're going to do is we're going to begin with Aurelia Bardois from James Monroe Elementary School in Edison, New Jersey, who's going to speak to us tonight on the mystery of chemistry. Aurelia?
Hi, my name is Aurelia, and I'm in first grade in James Monroe Elementary School, and I'm 7 years old, and I'm going to be presenting Mystery of Chemistry. Why study chemistry? Chemistry can be useful in explaining the natural world, caring for people for career opportunities, and producing informed citizens. Chemistry can help you satisfy your natural desire to understand how things work. Have you seen this in your day-to-day life? Like, why could apples turn brown upon exposure to air? Why sugar dissolves faster in hot water than cold water? Why the texture of eggs changes from runny to firm as eggs are boiled? Why water expands as it freezes, and why yeast makes bread dough rise? What happens to the compounds in bread when it is overcooked that the causes of the change in the taste of the bread? The compounds undergo a chemical change that changes the taste of the bread. They're broken down into solid carbon. That it would also get more blacker and more yucky. States of matter. Chemistry can be used to find evidence of life on other planets by analyzing light from stars and study their composition, like dwarf planets and gas giants, ice giants, and many more planets. A firefighter must know which chemicals to use to fight different types of fires, like forest fires, wildfires, electricity fires, gas fires, and many more fires. Like also last year, the Canada wildfire. States of matter. Matter is anything that takes up space, like a tree, a dog, a book, a house, water. Matter is composed of atoms. There are 3 main states of matter: solid, liquid, and gas. The periodic table. The periodic table is a way that scientists organize all the elements, which are types of atoms, that are present on Earth. They are organized by the atomic number, the number of protons in the nucleus. Each horizontal row of the periodic table is called a period. There are 7 periods in this periodic table. Within a period, the properties of the elements vary. Each vertical column of the periodic table is called a group or family. Elements within a group have similar chemical and physical properties. Fun fact: the similarity of colors and elements in the periodic table. The difference between purple and water. So purple is made out of 2 primary colors, red and blue. And water is made out of 2 primary elements, 2 hydrogen and 1 oxygen. If we put more red, it wouldn't be purple, and if we put more blue, it wouldn't be purple either. If they both were equal, it would become hydrogen peroxide. Chemical reactions, when 2 or more atoms bond together, they form a particle called a molecule. Water is known as H2O because it is a molecule that is composed of 2 hydrogen atoms in 1 oxygen atom that are chemically bonded together. Salt, carbon dioxide, sugar, hydrogen peroxide, and baking soda are just a few more of the millions of types of molecules that are all around you. Many of these molecules, like double hydrogen and oxygen, are like secret agents. Molecules. Molecules are 2 or more atoms bonded, which means joined together. Water is an example of a molecule. It is 2 hydrogen atoms and 1 oxygen atom bonded together. Salt is another molecule. It is a sodium atom bonded with a chlorine atom. When chemicals, which are atoms and molecules, mix, they undergo a chemical reaction, like color changing, bubbles, temperature change, and the formation of a solid or powdery substance. Chemical reactions. A chemical reaction is the process of breaking of chemical bonds in 1 or more substances and the reforming of new bonds to create new substances. So let's think. When you make pizza, which changes are physical and which are chemical changes? Pizza. The process of making pizza involves some physical changes, like chopping vegetables. The process used by yeast in the dough or by the gas stove to bake the pizza are chemical changes. Reactants: CH4, methane gas; O2, which is the air you breathe, which is also a gas. So first, to start the reaction, the energy gets added. Then the bonds get broken apart. And then new bonds come, like CO2, the carbon dioxide, H2O, water you form. And when they are bubbling, then that means a new gas is forming. And when it turns cloudy, a new solid will be forming. When it changes color, a new substance will be forming. When the temperature changes, the energy will be released or absorbed. And now this is the experiment, Monster Toothpaste. The purpose of this lab is to mix 2 solutions together and form a foam fountain. Let's learn a few things before the experiment. A catalyst is a substance that increases the rate of a chemical reaction without undergoing any permanent chemical change, like yeast. What is exothermic is that it will release heat and cause rise in the temperature of surrounding. To make the experiment, first, step 1, it will mix 1 tablespoon of yeast and 2 tablespoons of warm water in a small bowl until tiny bubbles form. Step 2, pour half a cup of hydrogen peroxide into an empty bottle using a funnel. Add a drop of food coloring and a dish liquid into the bottle. Step 3, use the funnel to add the yeast and water mixture to the soda bottle. Step 4, what happens to the mixture in the soda bottle? Monster Toothpaste. And the hydrogen peroxide will become 2H2 and O2. So they will break it into 2 parts, 2H2O, and oxygen will be O2. And what will help it break apart is the yeast. And when it blasts, it will look the same way here. Thank you.
Very, very nicely done. Very nicely done. Do we have questions?
I have a question.
Okay.
So, Arala, what is
So-
your favorite
oh,
part? You explained so many things. You explained so many things from yeast, from bread, over baking of bread and everything. What is your favorite part?
My favorite part is when it blasts.
When it blasts?
I have to
Monster.
try it.
Yeah. So it's very nice. You explained all the chemical reactions and everything. So cute.
Sophia, do you have a question?
Yeah, so from your presentation, it looks like you're really excited about this part of science. So what made you interested in learning more about chemistry?
What makes me interested that there's a lot of things in science, like science is everywhere.
Any other questions or
Anybody have
comments?
any questions?
Or you know you can use the raise your hand reaction. I
Yeah.
have a comment. You mentioned apples turning brown, right? Do the chemical reaction that takes place when the apple changes color, do you know anything about the Arctic apple that doesn't turn brown?
No.
Oh, since you seem very excited about chemistry, you should Google the Arctic apple because it's been genetically modified and it's not supposed to turn brown. So that could be interesting, especially since you're interested in chemistry.
I was right.
Yeah, very nicely done.
Very good.
Okay, thank you so much for sharing.
Aurelia, I was very impressed with your work. I will many blessings to you and your future endeavors in the science. Please do continue. This is the beginning, and I'm looking forward to seeing more of you, what you have to contribute to our community. Thank you so much for presenting.
You're welcome.
Okay. All right, so next up we have Sanvishri Chandran and Shrestha Kola from John Marshall Elementary School in Edison, New Jersey. And they will be presenting on an experiment to study osmosis using gummy bears. Okay, take it away.
Hi everyone, we're going to present an experiment to study osmosis using gummy bears. Hi, my name is Shrestha. And we're from Brion-Meisels School Elementary. And we're in 2nd grade. Hypothesis. When we add gummy bears into different liquids, they may lose their color, expand, and dissolve.
Sanvishri, we can't hear you. We can't hear you at all. Can you be a little louder or come closer?
The purpose of the study is to understand osmosis using growing gummy bears. The gummy bears get bigger or smaller after soaking in the liquids. Osmosis lets water pass in or out of a cell membrane to equalize the molecules in and out. The materials required: gummy bears, small cups, sugar, salt, water, vinegar, paper towels, kitchen scale, ruler, timer, paper, pen. Procedure. First, label each cup for a different kind of liquids like tap water, salt water, and vinegar. Then add a half cup of water to the tap water cup. And add a half cup of water and 1 spoon of salt to the salt water cup. And stir until it dissolves. Next, add a half cup of water and 1 spoon of sugar to the sugar water cup and stir until it dissolves. Next, add a half cup of vinegar to the vinegar cup. Now add 1 gummy bear to each cup of liquid and set a timer for 12 hours. After 12 hours, remove each gummy bear from its solution. Weigh the gummy bear and compare to the original groups. Note down all the results. Leave it for 12 hours. This is our experiment after putting it in the revision. Gummy bears are made of gelatin, a natural polymer. They do not dissolve in solutions. Instead, they grow or shrink. We observe that gelatin in gummy bears acts like a cell membrane in. Let's understand few terms. Osmosis. Osmosis is the net movement of water molecules across a semi-permeable membrane from higher water concentration to lower water concentration. Solute. A solute is a substance, usually a solid, that is dissolved in a solution, which is usually a liquid. Solvent. A substance that can dissolve a given solute and form a solution, really known as a solvent. Solution. A solution is a homogeneous mixture of one or more molecules, one or more of solutes dissolved in a solvent. Salt is a solute, water is a solvent, and if we mix salt and water, it makes salt water, that is a solution. After 12 hours, the tap water gummy bear grew, the saltwater gummy bear shrank, the vinegar gummy bear lost its shape, and the sugar water grew bigger. Tap water. Inside a gummy bear, there are more sugar molecules and less water molecules. Outside a gummy bear, there are more water molecules and there are no sugar molecules. So the water molecules will move from tap water to the gummy bear and the gummy bear will grow. Sugar solution. In the sugar solution, it has more water molecules than inside of the gummy bear. So the water molecules from the sugar solution goes into the gummy bear and the gummy bear gets bigger. Solution. Inside a gummy bear, there are more water molecules and less sugar molecules. Outside a gummy bear, salt molecules and less water molecules. So the water molecules will move from the gummy bear to the salt solution and the gummy bear will shrink. Vinegar. The vinegar has more water molecules, but it also has acid. So the vinegar goes into the gummy bear. The vinegar damages the semi-permeable membrane of the gummy bear. So the gummy bear loses its shape. And this slide shows weight comparison of gummy bears before and after treatment. In tap water, sugar water, and vinegar, their weight increase. In salt water, their weight decrease. Conclusion. Our results clearly show that osmosis causes water molecules to move across the semi-permeable membrane of the gummy bear from areas of higher water concentration to areas of lower water concentration. Where can we see osmosis? Examples of osmosis in everyday life. When we keep a raisin in water, it puffs up by osmosis. If you spend much time in water, your fingers will get wrinkled. The skin on your fingers absorbs water and expands by osmosis. Thank you.
Excellent, excellent. Right? That was really very interesting. And now I want to go home and I want to try the gummy bear experiment. So it's really a good way for you to explain to us osmosis. That was really interesting. Do we have questions?
I have a question, Miss Leonardi. It's Mike.
Hi there, how are you?
I am fine. Hang on a minute. Let me see if I can start my video. There it is. Hi, ladies. I enjoyed your presentation, and my favorite was the green gummy bear, if that means anything. But my question for you is, how did you weigh the gummy bears? What did you use?
We use a kitchen scale.
Oh, okay. And I saw some numbers on your graph. What did the numbers actually mean? Or what did they represent? They weren't pounds,
It
right?
shows the length, the weight of gummy bears.
But was
Right
it,
and up there.
it wasn't pounds though, was it?
No,
Do you know what units you used on your scale?
grams.
Oh, good, metric units. Okay, thanks for sharing. I really enjoyed your presentation, especially the green gummy bear who was doing this.
You,
Have a good night.
you too.
Any other questions?
Well, I have a comment. Very
Mhm.
good work, ladies. It was wonderful. Uh, I'm so happy to see the effort you guys have made in doing your presentation. And I could really see that many more will come in the future. So keep up the good work. Okay?
Okay.
Take care.
Thank you. Thank you.
Very
I
nice.
have, yeah, I have a question.
Mhm.
So if the size of the gummy bear increases, means what will happen to osmosis? Will osmosis increase or decrease? Like based on the size of the gummy bear.
It will increase. If it grows,
Mhm.
it'll increase, and if it shrinks, it decrease.
Wow. Thank you.
You're welcome. You're welcome.
Okay, so now we're going to move on to our middle school session. And first up, we'll have Sai Hasini Chandran from Thomas Jefferson Middle School in Edison, New Jersey, who's going to talk to us about waste management.
Hi. Can you see my screen? Okay. Today, I'm going to talk about a very important problem. It needs to be addressed immediately. If not, we're going to leave this mess for the future generation. If we can't handle this, they will also struggle to handle. Curious to know what that is? Waste management. Yes, it's that waste that we receive in various different forms, like plastic, paper. So here's some background information. Waste management is the processing and disposal of waste. It starts from direct waste segregation to complete disposal. So what kind of waste ends up in the landfill? We have industrial waste, household waste, hazardous waste, and construction and demolition debris. The waste in the US landfills, it can be recycled by 75%, but it's only being recycled by 32.1%. So what happens in the recycling process? What happens? So recyclable trash, it goes to the recycling plant, and then the recyclable trash is sorted and compressed into a big block called a bale. Buyers take the raw materials and they convert them into something new. This process saves a lot of energy than mining for virgin materials. So here's an example. Here we have our plastic waste. Then it is taken into the recycling center. It is sorted, shredded, and it is washed, and it's melted, and it's transformed into a new product. It saves a lot of energy. So what happens to recyclable waste that is not recycled? The waste are sent to landfills and they're mixed up and they're compressed to be as small as possible. Then it's covered with dirt for the anaerobic process to begin. This process causes landfill gas, it causes biogas to form. It can take several weeks to millions of years to decompose. Some are also sent for incineration, which produces toxins. So here's an example of the anaerobic process. Here we have household trash, and we have soil on top, trash, soil, and then we have trash on top. But why? So we have our initial trash, which takes around 500 years to decompose. So while it decomposes, we have even more build-up of trash. And here, this picture shares different types of waste and its fate. So here are the solid recyclable waste. They are turned into recycled products. And here are the organic waste, like the leaves, the stems, they are then turned into compost. And here are the segregated food waste. They are put into the digester, and there's the anaerobic digestion, and it turns into a biogas and digestate. And the biogas can be used as a form of energy in our for human needs. And other waste that are not recycled, they're sent for incineration, which means they're burned, and some are also sent for landfills. And here are some benefits of recycling. So it reduces CO2 emissions and it prevents a lot of toxins. And we get to have a healthy ecosystem for both humans and animals. And we conserve a lot of resources because we're not using up, because we're just using plastic and turning plastic. We're using the same material again. And we also save a lot of energy because we're not making plastic from the scratch, we're just recycling it. And it also saves a lot of money because recycled products are cheap. And we have this some sort of eco-awareness. We have this awareness of recycling and caring for the planet. And it uses less landfill space and it supports relation, as in it gives you a lot of communities to connect with while recycling. And here is waste to energy. So waste that cannot be recycled or turned into usable forms of energy, like heat, electricity, and fuels. And it can occur in a lot of ways, such as incineration, gasification, anaerobic digestion, landfill gas recovery, and pyrolysis. So this is how waste to energy actually works. So here we have our waste. It is then transported to the plant and then goes through this waste process where the waste is processed into energy that can be used, such as fuel, gas, electricity. So what problems does waste to energy
cause. It does cause a lot of problems. Like waste such as incineration and pyrolysis. Incineration is like the burning of waste, and pyrolysis is the melting of waste. These waste has a lot of heat, and of course it causes air pollution and many other pollutions. And it also emits harmful pollutants like lead, mercury, carbon monoxide, carbon into the atmosphere. And these are the problems that are caused by poor waste management, like air pollution, soil pollution, air emissions, and it also impacts a lot of animals, and it causes climate change, one of the lead causes. So here's the right way to dispose waste. But of course, we cannot have 5 different baskets in our house, so at least 3 different baskets, like 3 different bins. One for recyclable waste, one for organic waste, and non-recyclable waste will be really helpful. So what can you do as a citizen? What can you do to have your responsibilities? You can use recyclable items, and you could avoid plastic, and you can always try to segregate your waste instead of just like throwing all of them together. Just have this small awareness, and you could buy things that are needed instead of buying unnecessary items, which increases waste rates. And you could have the habit of donating extra mildly used items to people in need instead of trashing them. And you could be aware of what you dispose. Like sometimes people dispose fireworks and flammable chemicals, oils, and dumpsters can catch fire. And you can always create awareness through different platforms like social media, posters, your communities, etc. And you could also stop buying water bottles because 20 billion plastic bottles are tossed in the trash. So consider buying a reusable water bottle and boycott microbeads. Instead of using plastics, there are natural alternative things that you can buy, and you could obviously recycle. And you can also put pressure on manufacturers because buyers are going to keep buying, sellers are going to keep selling. Even if we know that we're buying a lot of plastic, we can put a stop to this cycle. We can put pressure on manufacturers, and we could let them to know that they could avoid using plastic.
1 minute.
Yes. Oh, and we can also ban, and we could do a lot of rules and regulations. And there are a lot of key challenges in waste management, such as like lots of population equal lots of waste, which makes a lot of waste is hard to manage, and there are a lot of illegal dumpings, and some people don't have the awareness of what to segregate. So these are some challenges, and there are no like right infrastructure to segregate waste. But here are some proposals. Innovation with AI, something with AI can help to segregate waste, and we can also have better infrastructure and better recycling facilities and composting plants. And stores can also have refillable stations for items with plastic. For example, if you're buying detergent, instead of like buying each, like you could have the container and go to the store and fill the liquid in, so that can save a lot of plastic. Thanks.
Very nice. Very nice. Do we have questions? I have a question.
Yes.
So I know in my town that we recycle, but we're not allowed to put our pizza boxes into our in with the other cardboard. Do you know why? Or maybe somebody here can help us out.
Or maybe
such a-
because the pizza boxes are contaminated with food, and so they're not like clean boxes that can
No,
be
I
recycled.
think it probably has something to do with the oil that maybe seeps into the box. It'd be an interesting, something to figure out
Yeah.
why that is one of the rules in the town, not to put pizza boxes in with the cardboard. And if no one else has a question, I have one more question. How do you think AI will help? What did you mentioned AI? What do you
Yeah.
think?
So I think that maybe AI can censor, and like it can like see what, like if non-recyclable waste enters into the recyclable section, it can like eliminate that and let the people know.
Mhm.
It can censor the waste.
Okay. And I think we have one more time, one more question from Aurelia.
If we have toys that have batteries and the batteries run out, then how do we manage those waste?
Yeah, so in many schools there are like they do have like battery recycling bins. So maybe you could check if your school has some where you could recycle your batteries, your old batteries.
But how do we recycle that?
I think, well, I think it goes in like I think it goes within the e-waste category, the category of e-waste, like with computers and yeah.
Okay. I think we'll go on then. Very nicely done. That's a very controversial and tough topic to take on, waste management. And I know it perplexes a lot of the communities throughout the world, I guess you'd say. But good job.
Yeah.
Okay, so next we have Ankanksha Narayan from Thomas Jefferson Middle School in Edison, New Jersey, who will talk to us about a comparative study between two cooling mechanisms.
Thank you. Can you see my screen? Am I audible?
Yep, you're good.
Oh, okay. Have you ever wondered what is the scientific reason for us using fans on a hot day? Actually, it is an example of forced cooling. I mean, you would not wait outside thinking that the wind would cool you off automatically, would you? I mean, it might take longer, or it might never be possible. And so this is what we are going to discuss more about today. So very good evening, everyone. I'm Akanksha, and I'm going to present a comparative study between the cooling efficiency of forced cooling mechanisms and natural cooling mechanisms. So firstly, I will discuss what exactly are these cooling mechanisms. Then hypothesis based on the efficiency of their working, testing the hypothesis, result, why is this so? And then finally, I would like to conclude my presentation. So moving on, natural cooling mechanism. It relies basically on the passive airflow. As you can see in the image, do you see these arrows? It shows how the air from outside enters the house and leaves from the other end without any other interaction with other wind forces or anything else. The examples of natural cooling mechanisms are cool breezes, cool nighttime air, anything that has natural air, just natural air without any interaction. So what is the importance of natural cooling mechanism? Natural cooling mechanisms, such as free air cooling, are increasingly being used in data centers to reduce energy consumption and operating costs because they're cost efficient. They allow fresh air ventilation that promote health and well-being. And of course, it won't be impacted if there's a power outage, right? But there are some limitations, such as it has a limited cooling capacity and seasonal limitations. The air outside won't be able to cool you off on a hot day, would it? Not really. On the other hand, forced cooling mechanisms relies on the man-made applications. As you can see in the image, the hot air is on one side of the fan, and on the other side, it is immediately cooling down, and the fan is giving off cool air. How is this working? Well, that is what we're going to discuss more. So, what is the importance of forced cooling mechanism? So, machinery generates heat during operation, which, if not properly managed, can lead to overheating and component failure. Forced cooling systems dissipate this heat quickly, maintaining the safety. They also provide rapid temperature control, tight spaces constraints in applications where there's no space to put on any other device. And then they help in customization to suit the specific space you want to use. But they also have some limitations, such as they use significant energy consumption and they give noise and vibrations, which in other terms can be disturbance. So based on what I have noticed, how people use their fans and it quickly just, gives the cool air, I believe the cooling efficiency of forced cooling mechanisms is more than the cooling efficiency of natural cooling mechanisms. Now I'm going to test this. For this, I took a glass of hot water with an initial temperature of 80 degrees. My room temperature at this time was 23 degrees Celsius. And then I decided to record the temperature of when the water was cooled by an external unit, fan in this case, which represents the forced cooling system, and where there was no interaction with any other external unit, which represents the natural cooling system. And this is me measuring some of the temperatures. This represents the natural cooling mechanism, and this is the forced cooling mechanism, where this is the fan. The results that I got when I graphed it into an actual graph, I was really shocked. The orange line here showcases how there was a temperature decrease via natural cooling, where there was no interaction with any other unit that helps in decreasing the temperature. But the temperature via external cooling was amazingly steep. See, the temperature went down so quickly, I couldn't even notice. But after a time, it stopped decreasing. But even though we can notice even after 40 minutes, the temperature via natural cooling system was really high than the temperature we got after using external cooling unit. So the results we observe is that there is a significant change using the forced cooling mechanism. And we can sum up that the cooling efficiency of forced cooling mechanisms is more than the natural cooling mechanisms. But why? Why is there a change between natural cooling mechanism and forced cooling mechanism? So convection. Convection is a process which says that hot air rises up and the cool air, which is denser, goes down. So this is what is followed by natural cooling mechanism. Since natural cooling mechanism means air in easier terms. But in forced cooling mechanism, the convection is normally happening, but the thing actually is when the cool air goes down, when the cool air comes down, the fan pulls the cool air towards itself and then pinpoints it to a specific location we want the air to go. Hence, in other words, it forces the air to go to a specific location. forced cooling mechanism, which forces the air to go to a specific position. And with this, I conclude that this study proves that the forced cooling is more efficient than natural cooling systems. And this is the reason we prefer to use hand fans when it is hot. Thank you, everyone. I hope you enjoyed.
Thank you. Thank you very much. It's very interesting.
Thank you.
Do we have questions?
I have a question.
Kiruthika?
Yeah. So how did you select this topic actually? We never think about natural world. Yeah.
Well, actually, this is pretty interesting. Science is something I love. And I don't know why. I'm always curious about the smallest things in life. And for some reason, I was just sitting there one day. I was feeling really hot. And then I decided that I would just use a hand fan. And that's when I paused. It was like, why a hand fan? Why? I mean, why am I using a hand fan? And that's when I decided that I would do a comparative study between forced cooling mechanisms and natural cooling mechanisms.
Do you think any side effects are there?
For?
Because we are forcing. Do you think any side effects are there because we are forcing the air, that cooler air towards one thing? We are just against the nature. Is there any side effects?
Not really, but so we're actually using a man-made application, which is a mechanical device that uses energy. So side effects is that it uses too much energy consumption, and it is overall impacting the environment in other ways, as it is increasing climate change, increasing temperatures, global temperatures. But in like simpler terms, if your question is like, if we force the air to come towards us, does it impact us also? I believe that that the cool air just comes towards us, and then it follows the convection process again from the area the air is pinpointed towards. So
I
not really.
don't think no side effects, because I have heard from few people, when they keep on sitting in front of fan for quite a long time, they used to get eye pain and irritation and something like that. That's why my
That
question
is
is.
because you're having forced. So when you have like forced air coming towards you, it's like forcing pressure, like too much pressure on your face. And yes, I mean that causes air pains. And yes, okay, yes, thank you.
Very good. Thank you. Thank you so much for this wonderful presentation.
Thank you. Thank you. I hope it was good. Thank you.
Any other questions?
I have one, Ms. Leonardi.
Go ahead.
Panksha, when you did your data collection, I liked your graph. Was the data collected for both trials on the same day?
Yes, it was.
And do you know what the room temperature was where you did the experiment?
23 degrees Celsius. I wrote it down, 23 degrees Celsius for both times.
Great. Thanks.
So is that the plateau on those graphs? I lost her. I think, oh, there she is.
Can you hear me? Can you hear me?
Yeah, now, yeah.
Yeah. I just was saying that I wrote it down. I took the data on the same days, and the temperature for both when I was collecting was 23 degrees Celsius for both of them.
And that was the plateau. That was the temperature of the plateau on the graph, right?
What?
I think on one of them, right?
Right, on the not the natural mechanism, the automated mechanism, that was the plateau temperature. It went down to 20 degrees C.
When
right?
it bottomed out and went level?
Right.
It actually, after 40 minutes, the forced cooling mechanism went down to the room temperature, but the natural cooling was still going down. So
very, very interesting.
Thanks.
Thank you very much. Okay, so Moving right along, our next presenter is Sanvi Alapati from Woodrow Wilson School in Edison, New Jersey, speaking to us about the digestive system. However, do we see Sanvi? I'm not seeing, is Sanvi here?
Oh, she's not here.
No, I guess not.
Donna, can you
Okay.
tell me what was the presentation name?
Digestive system.
Oh, no. We can move to the next one then.
Okay, we'll
Yeah.
moving right along. The next presenter is Shravani Pawar from Ramapo Ridge Middle School in Mahwah, New Jersey. This presentation is entitled Screen Time, the New Sleep Disruptor. Take it away.
Can you hear me? So my name is Shravani Pawar and I'm from Ramapo Ridge Middle School and my presentation is called Screen Time, the New Sleep Disruptor. So my agenda is my introduction, my hypothesis, my methodology, my results, my conclusion, and future research. And so the objective of my research is to determine if screen time has an effect on sleep quality. Consider this. Globally, people are spending 6 hours and 58 minutes per day on average looking at screens. For Americans, this number stands at at 7 hours and 4 minutes. Gen Z, aka those born between 1997 and 2012, averages significantly more, around 9 hours of screen time per day. Too much screen time can have a bad effect on health, such as eye strain, headaches, addictive behavior, reduced physical activity, and poor sleep. Blue light from screens signals the brain to stay awake, and that constant input throughout the day can make it difficult to unwind at night. Blue light is a part of the visible light spectrum. It has the shortest wavelength and the highest energy. It is most abundantly found in the sun, but it is found in artificial sources such as fluorescent light, LED TVs, computer monitors, smartphones, tablet screens, and other devices. Blue light exposure can cause long-term effects if used constantly. I wanted to research and learn more about the effect screen time, for example, exposure to multiple screens, such as TVs, phones, and computers, has on the quality of someone's sleep. So my hypothesis was that people with 2 or more hours of screen time after 5:30 p.m. experience a worse sleep quality than people with less than 2 hours of screen time after 5:30 p.m. So the method that I used was a survey research method. So I used a Google form to create a survey. And so some of my questions that I asked were demographics and qualitative and quantitative questions that I used to get my data. This is an example of a quantitative question I asked. And sorry, this is an example of a qualitative question I asked. And so for my analysis, I had my survey data summarized in Google Sheets, and I used the Google Sheets functions to calculate the average and standard deviation. And I used my data set to create graphs and pie charts to show correlations. So here are some of my graphs. So the first graph shows the age profile of the survey participants, and the second graph shows the screen time in a day. And so the average screen time was 4.1 hours, and the standard deviation was 3.1. So this next graph shows the screen time in the evening, which for me was after 5:30 p.m. And so the average amount of screen time after 5:30 p.m. was 93 minutes, and the standard deviation was 64. And the next graph shows the screen time right before bed. and the average in that was 22 minutes, and the standard deviation was 14. And this graph shows the correlation between the screen time in minutes after 5:30 p.m. and percentage of people who reported feeling tired. As the findings indicate, with higher amounts of screen time, the percentage of people reporting tiredness increases. This next graph shows the number of people who use a certain amount of screen time in a day and the percentage of those people who feel tired. And as the findings indicate, people with the least amount of screen time are the most relaxed. People with 120 minutes or less of screen time, in that category, only 1/12 or about 8.3% of the people are tired, while 70% of those with more than 240 minutes of screen time in a day report feeling tired. This chart shows the number of people who experience waking up during sleep versus screen time immediately before going to bed. And as evident in the data, the percentage of people experiencing sleep disturbance increases with higher amounts of screen time before going to bed. So my conclusion is that as the screen time hours after 5:30 p.m. and in a day increase, the percentage of people who feel tired also increases. I also learned that as the screen time before bed increased, the number of people waking up in the middle of the night increased too. And though I learned that screen time can have an important effect on sleep quality, my hypothesis of excessive screen time over 5:30 p.m. having an effect on sleep quality is not conclusive, which indicates need for further data gathering and statistical testing. So for future research, to extend my research, I would like to explore the effect on blue light on melatonin levels in the human body during night. Melatonin increases when it is dark, and the peak of melatonin is at 2 a.m. to 4 a.m. And a melatonin test measures certain hormones, such as melatonin and cortisol, that can help evaluate sleep quality. I would like to design an experiment by dividing participants in multiple study groups and by monitoring the screen time usage and melatonin levels and sleep quality every day for 30 days. Thank you.
Thank you very much. I think a topic that we're all guilty of, right? I just want to comment and say that every night I'm on my phone playing Candy Crush for the past 5 years, and then I do wake up in the middle of the night. So I think I'm going to try not to do that a few nights in a row and see what happens, right? So it's interesting. So do you have any thoughts about why it might waking up, after going to sleep, but then waking up? You have any idea about that? Like what might be the mechanism? The melatonin you mentioned peaks 4 a.m. or I think you said 3 or 4 or something.
I think it's called the circadian rhythm, which is like your body's natural sleeping system and times that you go to sleep naturally. And it can get disrupted if you sometimes sleep late a lot, or if you go to a different place and you experience jet lag.
So screen just before you go to sleep could perhaps be disrupting the rhythm, and then you wake up in the middle of the night, maybe. That's very interesting. Questions, Jason?
Yeah, first of all, I want to say that I think cortisol and melatonin are great variables to look at in a future study. But one point of criticism that I do want to bring up is you measured, one of the questions you asked was between feeling relaxed and feeling tired. And I am wondering if there might have been a better third variable, because I think in terms of going to sleep, I think there's overlap between them, unless I'm not understanding how you specifically define them. But I think, I don't know what word to use, but there must be a better word saying that, that the feeling that, when you're tired, but your body will not let you fall asleep, that is something that I think would have been, a good thing to ask.
Thank you. Other questions? Anybody? Aurelia?
What is fluorescent light?
Could you repeat that, please?
What is fluorescent light?
Wait, I'm sorry, my volume was really low. Could you repeat that?
What is fluorescent light?
She's asking what is fluorescent light? Can you hear?
Is that fluorescent light?
I don't really know much about fluorescent light, except I do know that it is a form of blue light, and
Thank you so
Yeah.
much.
Thank you.
Sharoni. It was great presentation. Thank you so much for presenting, taking the time to be part of our presenters and be part of this cohort. Great job.
Yes, thank you. Okay, next we have Miss Sophia Park from Eastbrook Middle School in Paramus, New Jersey, who will be talking to us about a study of materials for optimal combinations of thermal and sound blocking performance. Sophia?
Hi, my name is Sophia Park, and today I'll be presenting my research on a study of materials for optimal combinations of thermal and sound blocking performance. So to begin, when you think about what goes into constructing a home, many people think about foundation, designing, and framing, but something that's overlooked is soundproofing. So soundproofing is essential for any building, especially if it's a recording studio or an office, as having a quiet space is always needed. And simply insulating a building does provide some soundproofing qualities, but it costs between $2,000 and $24,000, which really doesn't leave much room to fully soundproof an area. So the objective of my research is to determine a cost-effective material with the best heat insulating and soundproofing qualities. I also wanted to research how certain materials have properties for both insulating and soundproofing, and what materials are the cheapest to efficiently do both. So I wanted to determine each material in the experiment for those properties and apply them to further research. My research question was, what cost-effective materials have optimal combinations of insulating and soundproofing properties? And my hypothesis was that if materials conventionally used for soundproofing and insulating are tested in both aspects, then the material most effective at both is best for protecting areas from outside heat and noise. So to begin, I used 5 different materials for the tests. So I started by making 5 boxes with 1x1 tiles of each material. They were 1 cubic feet, and the interior was about 1,000 cubic inches. To construct them, I used screws, hot glue, and cardboard, and I used duct tape on the inside linings to mimic caulk, similarly used to actual buildings. So for my soundproofing testing procedure, I used a decibel meter and a speaker with a set volume. Inside of one of the material boxes, I would set the speaker in the center, and I would place a decibel meter 1 feet away from the tip of the speaker. So I would have it play, and then once the reading stabilizes, I took that reading and repeated that 3 times for every type of material. I also had a control, which is the same test, but without a box. For the insulating testing, I used a dual probe thermometer and 2 cups. So 1 cup would be cup A, and that was my control. one of the probes would be in cup A and secured there, so that alongside my other tests with the material, I always had something to read off of. Cup B would be inside of one of the insulation boxes, and the second probe was poked through the top of one of the boxes. So I repeated this with every type of material so that I can compare it with their own controls. To test the heat, I used boiling water at 100 degrees Celsius and poured them into the cups at the same time. Once the temperatures read at about 93.3 degrees Celsius, I started the stopwatches and placed the insulation box above cup B, and I recorded this throughout 25 minutes. So for my soundproofing results, since I did 3 tests for each type of material, I found that each trial was within 1 decibel of the other trials, meaning that the test could be accurately reproduced and it was very reliable. Overall, to compare how each material performed, I compared this with the control that had no insulation. So on the graph on the right, you can see the subtracted decibels from the control for every material, and that shows that extruded polystyrene, foam board insulation, had the greatest decibels blocked, meaning it was the most effective, and the least effective was polyurethane foam, which is acoustic foam. For my insulation results, the way that I compared how effective they were at blocking heat was by comparing it to their individual controls. As you can see on the examples on the right, the blue lines show the control, and that was unique for each test since it was compared at the exact same time. The red line is the actual material and how it performed, which was the cup B, and the yellow line is the difference between the two. So a higher yellow line means that the material had a better job at blocking heat, and overall there was a bigger difference between it with the control. On the left is all of the materials and their temperature differences from the control, and the 2 most effective were expanded polystyrene and extruded polystyrene, and the least effective was the polyurethane foam. For the cost results, I found how expensive they were per square feet. The least effective was the most lowest cost was expanded polystyrene, which was styrofoam at about 60 cents per square feet. And the highest cost was the polyester fiber panels, which were 1 inch thick, and they went at about $6 per square feet. Overall, one conclusion that I had was that synthetic fibers are effective at soundproofing. Extruded polystyrene and polyester fiber panels were the most effective at blocking sound, and since both of those materials are constructed from synthetic fibers, it suggests that it's something that many people can look for in a soundproofing product so that it has optimal results. I also found that polystyrene insulation, in both forms of expanded and extruded, were effective at blocking heat, since the path of their temperature variances were very similar in my tests. Also, I found that polyurethane foam performed poorly in both soundproofing and heat insulating. Acoustic foam commonly comes in tiles, and they're often used in recording studios and offices. And these results suggest that while it's not effective at sound blocking on its own, it can be the most useful when installed as a support to a wall or a ceiling. My overall conclusion was that the material with the most optimal characteristics is styrofoam or expanded polystyrene. While expanded polystyrene had average performing results in soundproofing, it had the best results in insulating. It also had the cheapest cost out of all of the materials. So this suggests that overall in all 3 characteristics, it performed the best as an option combining everything. For future research, I would want to work with more materials to test, including more hazardous substances such as fiberglass or mineral wool that are used to mass insulate homes. I also want to research past materials that are only found in small quantities, since many are only sold in large packs. I would also want to find lower costs that can be put into these materials so I can create more access to quieter indoor areas by decreasing their overall costs. In all, I would also want to see the environmental impacts of each material, adding to determining the best material with how it impacts our environments. I would want to see their manufacturing processes, raw material compositions, and disposal and waste requirements. These are my references, and thank you so much for your time.
Thank you very much. I think we have a question from Mike Roche.
Hi, Sophia. Great presentation. Can you tell us more about the probes that you used?
So what I used was a dual probe thermometer, and the way it worked was that it had one screen and it would show both probes at the same times and what temperatures they had. So that way I could record what was happening in both cups at the same time while also not having to look back and forth where they are at a specific moment.
So on your graphs, it looked like your trial period was about 25 minutes. Did I read that right? So were you writing down temperatures every minute, or was a computer logging the data for you?
So for me, for the first 5 minutes, I measured it every 30 seconds, and then after that, I did every minute, and I did have to manually do it, which was a bit difficult,
Yeah,
but
that's a lot of work.
yeah.
It's tedious. Great. Okay, thanks. You answered my question perfectly.
Sorry, Sylvie, did you have a question?
Oh, no, I was just doing the clapping hands reaction. Good job.
Thank you.
I noticed that you waited till the temperature that was 93 degrees. Can you just talk a little bit about that?
The main reason why I waited for it to go to 93 degrees Celsius was because once I poured the boiling water between both cups, there wasn't much time for me to immediately put the insulation boxes on and immediately start the stopwatch. So by waiting until they were at that exact temperature, I could ensure that I would have more accurate results going on.
All right, thank you.
Usually in houses, practically, what material they're using? Like,
Sorry, could you repeat the question?
yeah, for insulating soundproofing rooms while building the constructions, what material is most widely used?
Really commonly used materials are fiberglass and mineral wool, and these are really intended for their insulation purposes and don't have as much soundproofing qualities as others, but they're really commonly used for their costs and also their effectiveness at what they do. I personally wasn't able to test them because of the limitations of buying them in bulk and also their caution with using them because they're irritants. So that's something that I would want to test in the future, and overall, they're really commonly used.
Thank you. Very good presentation.
Any other questions? Okay, thank you very much, Sophia. All right, moving right along, we have Isha Vandamala from Brooklawn Middle School in Parsippany Troy Hills, New Jersey, who's speaking with us tonight about nocturne insight. So do we have Isha? No, Isha? Okay, so
like Isha Vanamala last week only presented. She has done already.
oh, okay, because she was listed for this
Sorry.
evening,
Yeah,
so
yeah,
perhaps she
yeah.
switched her
Yeah,
night that
she
she
switched.
presented. Okay, so what we have is we have at this point a break. So I guess we'll take a 5 or so minute break and then come back for the remainder of the presentation. So we've done the middle school presentations, and next up we'll have the high school session. So if you'll come back in about 5 minutes, that would be great. Okay, thank you.
Hey,
Okay, if we'd all come back, I think we can get started with the high school session for the evening. We have next up would be Yashvi Rachwara from Bergen County Academies in Hackensack, New Jersey, speaking about music, mood, and memory. Oh, I'm sorry, Yashvi and Yuvika.
Good evening. Thank you for giving us the opportunity to present today. I'm Yuvika Ratheshwar, a 6th grader from Oradell Public School.
And I'm Yashvi Badeshwar, a 9th grader from Bergen County Academies.
We're excited to present our research project about the effect of music on mood and memory.
We both have been playing music for several years and realize that it is influential in many aspects of our daily lives. We can see music in sports such as March Madness that's currently going on, where we can see more exciting, upbeat music, and in places like churches and yoga studios, you can see more calming music. Now, people with short-term memory loss from diseases such as Alzheimer's disease often recognize familiar songs such as Happy Birthday, which are encoded into their long-term memory. We may not realize it, but music actually activates many different parts of the brain, including the temporal lobes responsible for tone and pitch, the cerebellum responsible for rhythm, timing, and physical movement, as well as the hippocampus and amygdala responsible for emotions and memory.
There have been many studies done to look at music's impact on the brain. Kids with musical backgrounds during childhood have better brain growth, functioning, and development in their adulthood. Music can improve oxygen saturation and respiration rates. It can also improve sleep and memory behavior, especially in patients with memory loss. Music can overall affect emotional well-being. Experts are trying to understand how our brain can hear and play music. A stereo system puts out vibrations that travel through the air and enter the ear canal. These vibrations tickle the eardrum and are transmitted into an electrical signal that travels through the auditory nerve to the brainstem, where it is reassembled into what we perceive as music.
So, you may be asking, why did we choose to do this project? Well, we've found great sources of joy in playing the piano, and as a part of our yearly piano recitals, we played at for senior residents at assisted living homes. I would love seeing their smiles and them tapping and nodding along. And also, memory loss is a big concern among these senior residents, so both of us were really curious to assess the effect of the music on both the memory and the mood of the senior residents.
It is believed that listening to one song can greatly improve the mood of people. Our research question was, how does music affect the mood and memory of our senior citizens? We hypothesized that we can use music as an effective tool to improve emotions as measured by mood, energy, state of mind, and memory.
So, we visited 2 senior residence homes in New Jersey, Sunrise and Bristol Assisted Living, and what we did was we gave them a pre- and post-concert survey. This pre-concert survey had mood, energy, and state of mind with a score from 1 through 10, 1 being the least, or for energy, for example, the most tired, and 10 being the most awake. And we also had a 3-word memory recall in which we gave them 3 words, for example, captain, banana, and river, and we told them that they would be asked to recall these words later. Then we had them draw a clock, put the hands to 10 past 11, and then we asked them to write down the 3 words that we had asked. And we did this again, and instead of having them draw a clock, we played one song by Clementi on the piano as it was a happy song. And the way we scored this was they got 1 point if they got the clock entirely correct, 0 if they got it wrong in any way, and 1 point for each of the 3 words they got right.
We collected the survey sheets and took them back home, where we used Google Sheets to statistically analyze the data, which we used Google Sheets to graphically depict. We included averages, standard deviation, t-tests, and correlations. We also included statistical significance.
So this is a bar graph with all the participants' ages, with them ranging from 73 to the oldest of 99, the average age being 85. We also had a pie chart of the males and the females, with it being 85% female, which was the majority, and 15% male.
This is the results of our energy part of our pre-concert and post-concert survey. The x-axis depicts the 26 participants, and the y-axis depicts their scores from 1 through 10. The blue bars represent the pre-concert survey, and the red bars represent their post-concert survey score. This pie chart shows how many people had a decrease or increase or the same score before and after the song was played. For the light red is no change in energy, which is 12 out of 26 or 46%. The same amount had an increase in energy after the music was played, and 2 people had a decrease, which is 8%.
We also showed the averages of the energy scores, with them averages from 0 to 10 being on the y-axis and the participants being on the x-axis. The blue was representing the pre-concert and the red represented the post-concert. We added the standard deviation bars, and the pre-concert was 4.5, which increased to 5.6 after. The p-value was 0.02, which shows that the data was statistically significant as it's less than 0.05.
This is our results for the mood part, where the same thing, the x-axis is the 26 participants, and y-axis is their scores in mood from 1 through 10. The blue bar is the pre-concert score, and the red bar is the post-concert score. The pie chart is the same, where the light red is the same score from after the song was played and before the song was played, which is 9 people or 34%. The red is an increase in mood after the song was played, which is 15 out of 26 or 58%, which is more than half. And the blue represents a decrease in mood, which was 2 out of 26 or 8%.
We also depicted the averages again, with the blue being the pre and the red being the post, and their standard deviation bars. This time the average was 5.1 for the mood, and it increased to a 6.5 after, which was an increase of 27%. The p-value was 0.04, which shows that the data was statistically significant.
These are our results for the state of mind, and it's the same thing where the x-axis is 15 participants. It's different because we only had the state of mind survey in one of the senior resident homes that we visited. The y-axis is their scores in state of mind from 1 through 10, and the blue bar is their pre-concert score, and their red bar is the post-concert score. For this, their light red represents a decrease, the light red represents the same score after the song was played, which was 2 out of 15, which is 13%. The red represents an increase, which is 11 out of 15, or 74%, and the blue represents a decrease, which is the same amount as the people who had the same score, which is 2 or 13%.
So for this one, the average before was 4.8, and it increased to a 7.4 after, which was a 54% increase. The p-value was 0.007, which being less than 0.05 showed an extremely statistically significant increase.
So this is our clock drawing. So 10 out of 26 of the people of our senior residents were unable to draw the numbers and place the hands at 10 past 11 like we instructed them to, while 16 out of 26 were able to accurately make the clock and got a score of 1. The pie chart shows where the red is people who were able and got a score of 1, and the blue is people who weren't able and got a score of 0.
This shows the participants and each individual from before and after for their memory recall scores, and then we also did another one with the average, with it being 2.4 before, which increased to 2.6 after, and the p-value was 0.01, which represented a statistically significant increase.
2 minutes.
This is the pulse bar graph, which showed the pre-concert pulse and the post-concert pulse. The pre-concert pulse was 64, and the post-concert was 74. We had a lot of varying pulses for some of the people after multiple checks. This might be caused by medications or medical conditions, but the p-value was 0.06, which is not less than 0.05, but is very close. We also asked the song, have you heard this music? That question, have you heard this music before? To see if they were biased for their answers. 96% said no, which is the majority, and then 4% said maybe.
So our conclusion was that our hypothesis was proven, and music had a positive effect on memory as well as mood, energy, and state of mind. And this was shown through the senior residents and their ability to recall more words after the music was played, which was the one Clementi song on the piano. And the average energy, mood, and state of mind had increased significantly. And also the pulse increased, but it wasn't as significant, yet it still increased.
We had some limitations during this, which included visual stimuli because of us visiting and playing for them. They might have just have their energy, mood, and state of mind increased because they don't get that often. There could have been medications that affected the pulse. There were also many physical limitations because a lot of them had tremors due to strokes. So we had to assist them in writing, and yeah. We want to thank Miss Pam Wiley, our beloved piano teacher, who inspired us to pursue our love of music, and she also let us play at the senior residence home, which paved the way for us to complete this project. We also would like to thank the enthusiastic senior residents and volunteers, without whom we could not have completed this project.
Thank you.
Thank you very much. Do we have questions? Kiruthika.
Sorry if I missed. How did you measure the energy, mood, and state of mind? Can you just explain that? Sorry if I missed in your presentation.
So we used the survey where 1 was tired and 10 was aroused for energy, for example. So we gave them a pre-concert survey before the song where they rated all 3, and then we played the song, and then we gave them the post-concert, and then we compared each person's results.
So how did you select the songs? Because the taste of people is completely different, right? It varies from each and everyone. So
Yeah.
how did you select the song? And yeah,
So we chose one specific song so it wouldn't mess up the results. And we did one that was by Clementi's, a classical song, and it was a very upbeat song, so that's why we chose the song we did.
that's great. Thank you.
More questions? Did you have to, how did you explain for the residents to monitor mood? Like, did you define, a change in mood, a change in energy? Like, how was a change of energy explained to them to be able to rate a change of energy? I'm just curious.
So we decided to use emojis so it would be easier for them to understand, but we also had to explain to some of them, like that 10 was the highest. And so yeah, it was basically just emojis, and if they had any questions, we would answer them.
Yeah, so some of them were a little confused because they couldn't understand it, so we would come and we would explain them to them individually and explain like the emojis and the numbers and like exactly how it works so they would understand it better.
Can you explain us now, like how energy, mood, and state of mind, like how you explain to the senior citizens?
So for the energy, we did 1 being the most tired and then 10 being aroused. And then for mood, 1 would be more sad and then 10 would be joyful. And then for state of mind, it would be with 1 being most anxious and 10 being the most calm.
So we would try to like ask them, are you tired or are you calm? And then they would say like, I'm tired or I'm
Somewhere
like,
in between or
yeah.
Okay. It's cool.
Okay, thank you very much.
Thank you.
Very interesting. And the use of statistics is very impressive.
Thank you.
Okay, let's move on. So next we have Ms. Maggie Kelleher from Marine Academy of Technology and Environmental Science in Manahawkin, New Jersey, who will talk to us today about employing woodpecker cranial adaptations in a novel helmet design for increased impact protection.
Can you see my screen? Can you hear me?
Yes, we can.
Cool. I'm Maggie Kelleher, and I'm here today to present my research on employing woodpecker cranial adaptations in a novel helmet design for increased impact protection. Let me start by providing a little background. I'm sure many of us are familiar with hearing about traumatic brain injury in the news. You see these football players crashing into each other and suffering effects such as anxiety, depression, and sometimes complete personality changes. This is traumatic brain injury, where a blow to the head causes the brain to make translational movements within the skull and crash against it. This condition is not only acute, it can be chronic, with the 5-year outcomes of traumatic brain injury sufferers in the US having had only 26% of people improved, while a combined total of 74% stayed the same, became worse, or died. This all contributes to traumatic brain injury's major socioeconomic burden, where the annual global cost of traumatic brain injury is approximately $400 billion. Luckily, helmets can reduce the risk of head injury by 85% and brain injury by 88%. Woodpeckers actually use similar methods to helmets to prevent traumatic brain injury. This allows woodpeckers to peck trees 8,000 to 12,000 times a day with forces that are up to 14 times as much as it would take to give a human a concussion, all without suffering traumatic brain injury or incurring any impact to their health. They allow for impact dispersion over a larger surface area, cranial deceleration over a longer period, and energy absorption through compression. The impact force travels along the beak to the hyoid bone and tongue, across the spongy bone and the hard cranial bone, and around the base of the skull. The beak takes the brunt of the impact, and then the hyoid bone and tongue contract, acting as a seatbelt mechanism and dampening the forces that act on the skull. You have these layers upon layers of absorption that spreads out the force that the woodpecker endures at any given time. This is the spongy bone highlighted in red. Once the impact force is dampened by the tongue, it gets dispersed by the spongy cranial bone. This cancellous cranial matrix scatters the impact force as it slightly compresses, providing elasticity while absorbing the impact. Finally, the hard cranial bone neutralizes any of the remaining impact force. This is the mass stamper spring model. It's a kinematic model of the woodpecker's drumming motion when it hits a tree. It's read from right to left. As the force travels along the hard beak, hyoid bone and tongue, the spongy bone, and the hard cranial bone, their mass, stiffness, and dampening properties each work together to result in as little brain displacement as possible. The first major absorption is by the beak, and the force sequentially decreases. By the time it's traveled across the beak, hyoid bone, and tongue, the force has been reduced to nearly an eighth of what it originally was. Once it reaches the skull, the spongy and hard cranial bone work to scatter and disperse the impact force even further. This allows woodpeckers to drum into trees at a rate of about 22 times per second with a deceleration of approximately 1,400 times the force of gravity, all without injury. In contrast, gravitational forces of only 4 to 5 would cause the majority of people to lose consciousness. So, because of the effectiveness of the impact force protection they provide, I used these woodpecker structures as the basis for a novel helmet concept that was designed, built, and tested over the course of this study. Up top, you have a diagram of the woodpecker's spongy cranial bone, where you have the gaps and the bone that disperse the impact force. I use this as a basis for a 3D model that I made that mimicked these gaps and the helmet liner itself that I would use in this helmet. This sponge disperses the impact and provides so much protection. After experimentation with different materials and issues with 3D printer errors and combined with extruder errors and a whole mess of things, I had to pivot and make a mold of the helmet interior using paper mache and straws, along with some wire. I then filled this up with EPS beads and closed it off and added a helmet the shell that acts as the hard outer beak and hard bone, the interior that acts as the spongy bone of the woodpecker, the padding that acts like the hyoid bone and tongue seatbelt mechanism, and the straps that further acts as that seatbelt mechanism. It was filled with EPS foam beads, which is a compressive material that helmet interiors are typically made of. For my testing, I tested this compared to a consumer grade helmet. The watermelon was used because it has the same density as a human head. The helmets were dropped from a series of increasing heights until their respective watermelons broke. It was hypothesized that the woodpecker-inspired helmet would better protect the analog head than the conventional helmet would. For my data collection, I used a series of kinematic equations to calculate the impact velocity, impact force, potential energy, kinetic energy, and energy absorbed by each drop. And the impact time for each of these equations was assumed to be 0.01 seconds, since it was an instantaneous bounce and I wanted to have a control. In a situation where an object is dropped, as was done in this experiment, the object's potential energy is highest when it's at an initial height. It then decreases as it falls and is converted into kinetic energy. Upon impact, the force causes the object to depress, and the potential energy increases again with the rebound. When it bounces, it will not return to its initial height because some of the energy was lost upon impact. This lost energy was the energy absorbed by the dropped object. It then falls again. For the sake of the calculations in this experiment, the helmets were dropped after one bounce. Let's watch it happen. You have the drop, the inset before the impact, it depresses, bounce back up, goes to the top, falls again, and is stopped after one bounce. For my data analysis, I found that the woodpecker-inspired helmet was able to absorb a total of 82 joules while still protecting the watermelon, while the typical bike helmet was only able to do so for a total of 69 joules. Though both watermelons broke after being dropped from the same height, this reveals that the woodpecker-inspired helmet prototype worked better at withstanding and distributing the impact force than the commercially sold bike helmet did, supporting the hypothesis. Then I wanted to look into the cost effectiveness of this. And so I illustrated a hypothetical for calculating the potential expenses of mass manufacturing woodpecker-inspired bike helmets. The main difference from my methodology I circled in red here. Here I replaced the straws with machinery to shape and commercially fuse the beads. This improvement would remove the parts of the helmet liner, the straws in the metal wire, that could damage the structural integrity. After testing, I had observed that the main sites of the breakage were where the wires and the straws had been poking out the most. Because these wires and straws weren't spread out, all the force was concentrated there and leading to the break there. However, using removable machinery that would come in and fuse the beads and allow for steam fusion would get rid of this issue, and we wouldn't have to have those straws and wire in the helmet anymore.
2 minutes.
So, based on research of current commercial costs, the predicted manufacturing cost of a woodpecker-inspired bike helmet is about $7.33, with retail around $14.66. The predicted cost comes from $3 for newspapers, 32 cents for flour, 1 cent for water, 55 cents for wax, and 40 cents for EPS beads, plastic of the shell, and helmet straps, as well as other costs such as 30 cents for manufacturing, 40 cents for packaging and warning labels, 75 cents for shipping costs, 20 cents for lab certification costs, $1 for miscellaneous business overhead costs, and 40 cents for marketing. Based on these parameters, the helmet it was tested against was estimated to have cost $8.56 to make and was sold for $17.11. Based on this setup, the helmet it was tested against is based on this setup, the woodpecker-inspired bike helmet is not only better at force distribution, but also has the potential to be cheaper at about $7.33 to make, making it $1.23 less to make than the consumer grade bike helmet. Overall, the woodpecker-inspired helmet can offer greater levels of protection to the consumers than the consumer-grade bike helmet at potentially $1.23 less to manufacture, supporting my hypothesis. And while still protecting the watermelon, the novel helmet was able to withstand and distribute a total of approximately 82 joules, while the consumer-grade helmet was only able to do so for approximately 69 joules. This was due to my helmet's imitation of the woodpecker's anatomy, contributing to the effectiveness of its impact dispersion, energy absorption through compression, and cranial deceleration over a longer period. Potential ways to take this project even further would be to test multiple of the novel helmet prototype against multiple different types of helmets, but unfortunately, due to time, cost, and material limitations, this was unable to happen during the course of this study. However, this design still has a large variety of potential applications, such as incorporation into protective wear with helmets, body armor, and shields, as well as incorporation of the components into shock-absorbing systems such as cushions, dampers, bumpers, and vehicle armor, and more. Hopefully, a helmet design such as this could help to mitigate the major socioeconomic burden caused by traumatic brain injury, while also being accessible due to its low cost. Thank you.
Thank you very much. Jason, you have a question? Very nicely done.
Thank you.
Yeah, that was a very interesting presentation. Thank you, Maggie. One of the questions that I had is, where did you get the idea to study a woodpecker skull?
I had been looking into different topics of research, and I had come across that woodpeckers don't get traumatic brain injury, and I thought that was really cool. And I looked into the different structures that allowed them to do that, and I figured that if I could apply this into some sort of helmet, that I could utilize the same structures that they employ and utilize it for human benefit.
Any other questions? Kiruthika?
Yeah. So for your helmet, what are the materials you used? I heard straws, then paper, newspaper.
For my helmet, I used paper mache. I'll go back to the slide. I used paper mache, straws, and wire, along with other like hot glue and such. And then I filled it with EPS foam, expanded polystyrene foam beads. That's the type of foam that you see in typical helmets.
Oh, okay. So, so you use the same material which they use in the commercial helmet also, apart
Yes.
from this,
apart from
this
that
straws.
mold.
So,
yeah.
What is the main difference between that and this? So this works better. Like you say that it disperses that vibration. So, what is
Because
the
of the
main difference?
gaps in the prototype, those gaps that are mimicking the woodpecker's spongy bone, the dispersive properties of my helmet are different than that of a typical helmet, and because of those gaps, the impact force is dispersed before it even reaches the head, and it has longer period to depress, and the cranial bone has a longer deceleration period, and it slows down and decreases the force absorbed by the human.
So interesting. Just introducing some gap can make this much difference. That's so interesting. Yeah, that's cool. Thank you so much for this presentation.
Thank you.
Other questions? Maria?
Hello, very well presented. So I really love the fact that you mentioned because of these gaps. I'm thinking of, how bone, the spongy bone part of a bone, how it is, still strong and we still have it. It's very when you reduce the breakage. My question for you, great work, by the way.
Thank you.
I'm looking at your prototype, right? And I'm thinking all the time think of how will we sell this? I look at your prototype in terms of face forward how would you improve it in a sense that is easy? Because honestly, I tell my son all the time, wear your helmet, wear your helmet. He tells me, I don't want to wear my helmet. Come on, mom. It is not. So how do we get kids to actually, I mean, this, aside from the safety, to actually make it in such a way that it's ideal for them to buy or wear? Because parents will
For
all the
them,
time purchase these helmets. It's just the issue of them wearing it.
oh,
Like,
for them to want to wear?
yeah, aside
I
from the
think
safety.
the cool science aspect of like, hey, you're like a woodpecker if you wear this. You can do cool things like woodpeckers. I think could be a fun selling point with like a little woodpecker mascot or something.
Oh, that's so cool. I like that. I like that. But very good job. I see you're the products of mates. As always, I
Yes.
have gone to your school. I'm always impressed by your school, and the students are great. So thank you for
Thank
joining
you.
us today. And hopefully I'll see you at the April 20 and see all the presenters April 20. Please do not forget. Okay. We will be sending more information on how to register for that event. Highly recommended. You will be able to see more the Junior Academy research presentations and maybe how can you improve or look forward to do similar work in the future. So hope to see you there. Take
Thank
care.
you.
Thank you so much.
And I just wanted to add a comment as well. I recently saw a presentation on the use of metamaterials and the design of the spongy bone. I
You
feel
cut
like,
out.
am I there? Can you hear me?
Oh, yeah, I can hear you now. Sorry.
Okay, so I recently saw a presentation about metamaterials and the different configurations of a metamaterial, like almost like the soles of the sneakers that have holes in them and everything that are, it's a physics problem. But I wonder
Yeah.
if looking at the spongy bone that you're mimicking, whether that is, could that be improved? I mean, the woodpecker seems to have it right, but I wonder if the spongy bone design could be, modified a little bit. And also, I wonder if you've actually thought about bringing this to someone. Ironically, I actually have an acquaintance who they design helmets for the service, and they do pilot helmets. And I was just fascinated when I visited their business location, and they just basically design helmets. So the
That's
whole
so
time I was
cool.
thinking, oh, that's so cool. Yeah, so anyway, I would be in touch, and maybe you can at least talk to them or something like that. So I'll be in touch at another point in time with you if you'd like.
Yeah, I would very much love to have their contact information.
Okay.
Thank
All
you.
right. Thank you so much, Maggie. All right, moving right along, we have Aditya Trivedi from John P. Stevens High School in Edison, New Jersey, who will talk to us about the utilization of nanoparticles in the treatment of type 1 diabetes.
Hi, yep,
Hi.
thank you. So I'm going to share my slides right now. All right, can you guys see this? Hello?
Yes, yeah, we can hear you and see you.
Thank you. Hi, so my name is Aditya Trivedi. I'll be presenting the utilization of nanoparticles in the treatment of type 1 diabetes. So some background information. So as we know, type 1 diabetes is a disease which affects kids and adults around the whole world. Primarily, it affects 10% of the whole population around the world. It causes them to have unregulated blood sugar levels due to their body having an autoimmune reaction, in which insulin producing beta cells are destroyed. As of right now, scientists do not know the reason, but insulin relies a very important part for your body as it regulates your blood sugar levels by directing your blood sugar into the body cell so that they can be energized. Also, insulin signals your liver to store the blood sugar for later use. So, what are some current methods for type 1 diabetes? So first of all, we have insulin injections, in which daily injections are administered after a meal. It is highly recommended that they be injected multiple times throughout a day to ensure that the blood glucose level stays the same. At the same time, we have insulin pump therapy, in which the insulin amount needed for your blood sugar level is programmed by the machine over here, and then eventually you can administer yourself the insulin. At the same time, we have artificial pancreas, which is one of the very brand new treatment methods for insulin and type 1 diabetes, because it tracks your glucose levels every few minutes and then ultimately delivers that insulin to your body. And lastly, we have islet cell transplantation, in which this is a process that involves the transplantation of insulin producing beta cells from a donor into the patient who has type 1 diabetes. So, all of these methods involve injections or some sort of way which involves having the patient to be administered from the outside part of the body. My treatment method is a new treatment method in which nanoparticles can be used to deliver insulin. I want to achieve this by successfully delivering nanoparticles into the lung, in which a diffusion from the alveoli to the bloodstream can be allowed, and this method also prevents insulin degradation, thus allowing direct delivery of insulin molecules to the bloodstream. So first of all, when my nanoparticles would be inhaled, they would obviously face some limitations. These limitations involve macrophages inside the bronchioles, bacteria, viruses, and other white blood cells. When they arrive to the alveoli is the most important part in this process, as the alveolar capillary membrane is the part where my nanoparticles would be able to be diffused and eventually allowed to administer insulin. So as you can see over here on the second image on the right, this alveoli is also the site of gas exchange in the lungs, and this process is important because my nanoparticle would be using this process to be diffused into the bloodstream. The gas exchange process is basically the process that involves the implementation of oxygen into your bloodstream and carbon dioxide coming out of your bloodstream. So learning about the gas exchange, I had to learn about Fick's law of diffusion. So Fick's law of diffusion is a process and physics formula which explains the gas exchange process that occurs at the alveolar capillary membrane. In Fick's law, the characteristics that are governed are the membrane thickness, molecule size, molecule concentration, and surface area. And all of these factors will help determine if my nanoparticle can even diffuse through the barrier. So as such, I tried to code a alveolar diffusion model in Python, which would help me to determine if and test my hypothesis, which is that the flux of the nanoparticle is ultimately dependent on the nanoparticle radius and concentration. It was involved a lot of high level coding, and I had to code Fick's law of diffusion into the Python itself. So after creating my alveolar diffusion model, I was able to generate my graphs, which are my data, and these show that the two main factors, particle radius and particle concentration, how do they affect the flux, aka the diffusion rate of my nanoparticles. So these two graphs, and especially the flux versus particle radius, it is an inverse relationship in which the flux would get larger as the radius decreases. And meanwhile, the relationship between the particle concentration and flux is a direct relationship in which the flux will increase as the concentration increases. So, analyzing from both of these graphs, I was able to factor on what would help create the best nanoparticle. For my nanoparticle radius, the best nanoparticle radius to treat type 1 diabetes would be at 10 nanometers. So analyzing from the graph, I got to this number since even though a nanoparticle can range in 1 to 100 nanometers in diameter, the most realistic standards would be between 10 nanometers and 50 nanometers, since also this is a size being used to treat cancer and drug delivery. Analyzing the second graph, the best nanoparticle concentration would be 50 nanograms. And this is a very important number since a concentration of 1 microgram would suffocate the patient, as the air spaces in the alveoli are within 0.2 micrometers of the capillaries, which is a very thin barrier to diffuse. So if our concentration was to get any larger, it would suffocate the patient and eventually not allow nanoparticles to be reached to the bloodstream. So now comparing this method to others, it shows that currently most methods of type 1 diabetes cannot factor out hypoglycemia. All other treatments except artificial pancreas aren't able to combat this problem, but artificial pancreas is not a treatment method as accessible to people all around the world, since it's very expensive in the range of $5,000 to $8,000, and this would probably mean that patients who live in poverty and affected by type 1 diabetes will not be able to access this treatment method. So nanoparticles can combat that problem by being less expensive, in which the estimated range is between $420 to $700 for manufacturing, and they would also be programmed to deliver 2 batches of nanoparticles, in which one would contain fast-acting insulin to stabilize the high blood sugar after a meal, and the other batch would encapsulate long-acting insulin to keep the blood sugar concentration sustained. And this is how this nanoparticle would also combat the problem of hypoglycemia. So from my conclusion, after creating my alveolar diffusion model, even though this model that I created shows that a nanoparticle respiratory delivery system is possible, it should be further implemented in research, since developing this system will also allow scientists to combat other diseases besides diabetes. And nanoparticles have also very specific advantages, such as biocompatibility, reduced toxicity, enhanced permeability, retention effect, and precise targeting. And this is my works cited page.
Okay, thank you very much. Questions? Very nicely done. NanoCheck is big business now, right?
Yes.
Could I ask you how you determined the concentration, the appropriate concentration of the nanoparticle? It's encapsulated, it's a self-assembling, is it? Do you actually intend to create the nanoparticle? Or this is your hypothetical?
As of right now, from research I have found online, most nanoparticle concentrations are between these parameters. And for right now, this is only a online model of through coding, in which I showed that it's possible to create a nanoparticle system in which there can be administered to the bloodstream, but there are a lot of factors that play on if this process is able to be in real life. Like I said before, we have macrophages. At the same time, we have to consider how much nanoparticles can also not get delivered and diffused properly through some error as well.
So what did you mean by a high concentration would be suffocating? Could you explain that?
Yeah, so the barrier inside the alveoli, like I said, is 0.2 micrometers. So if we were to have a very large concentration, which is like a large amount of nanoparticles, if they're bigger than 0.2 micrometers, they would ultimately get stuck into the alveoli. And alveoli is where we have our gas exchange. So if they get stuck, oxygen cannot go into the bloodstream, carbon dioxide cannot come out. And in this way, it would suffocate the patient.
Okay, thank you. Any other questions?
Yeah, like, so how did you get into this diabetes, type 1 diabetes, and
So,
why?
so for me, it starts off with my grandparents. All four of my grandparents have type 1 diabetes, which means that I'm at a very high level risk to get type 1 diabetes as well later in my life. So, as of right now, hopefully, if I don't get it, and if I do get it, what are the treatment methods possible for me? And all of these treatment methods or can be too expensive, or at the same time they have a very certain risk, as I've said before, like hypoglycemia. And I wanted to ensure that is there a new treatment method I can discover and possibly implement later in life, and be further research that can affect as a more less costly method, and also eliminate other factors of risk as well.
It's cool. So, I'm not much into nanoparticles. So, how will you bind the nanoparticles and the insulin?
So, first of all, there are multiple different types of nanoparticles. The one that would be administered for this type of treatment is called lipid nanoparticles. So they are different because they're more biocompatible since they're made of the protein lipids. And for them, they are in the shape of a circular cell in which the insulin can be encapsulated in itself. As we know, all insulin that's used for medicine is like grown in the lab, and at the same time, this insulin would be used in the treatment method by through encapsulation, in which we would use the technology that's in the lab to do by hand put them inside the nanoparticle.
So, it is by your method, we have to, how do you deliver the drug? How do
Yeah.
you deliver?
So, we would be using an inhaler similar to asthma. Like asthma is a very common disease around the world, and if most people probably have seen an asthma inhaler and know how to use one, and this would mean that it'd be easier for people to understand how to use the inhaler to deliver the nanoparticles.
So, because we are delivering insulin,
Mm.
is there will be there should be some regulator in that inhaler, right? Because too much of insulin delivery also cause, means it cannot be used just like an inhaler. Do you understand? Like
Yeah.
the amount of insulin which you are delivering inside your body also is very important. So do you have any plans for that as of now?
So as of right now, I have not, answered that question like problem yet. But I feel that if I were to have a answer for it right now, it would probably that the specific amount of nanoparticle concentration that needs to be used each time would be delivered. Because so these nanoparticle concentration would be two batches, one for rapid acting and one for long acting. So then it ultimately mean that the average human who consumes the calories, it would be based on that. And then eventually it can be specifically targeted to people's different calorie lifestyles. Like how if they take a higher calorie, then they probably need a batch of nanoparticles that have better rapid acting insulin, as etc.
Thank you so much.
And we have time for one more question, Jason.
Yeah. So my questions are, you said earlier that this would be a phospholipid or a phospholipid protein membrane, and how do you know how mechanically how they control the size of those of the membrane that you create?
I don't know the detailed process. Like this is where it's involved very specifically in the lab. For me,
Okay.
I was just able to find out that from all the different types of nanoparticles we have, this would be one that'd be best used for this delivery system because it's more biocompatible. And maybe because it's more biocompatible, this would mean that macrophages who attack foreign objects would probably not discover this lipid
Yeah.
nanoparticle because it's more similar to the body structure.
That makes sense. And in regard to the previous was discussed before, I understand that there are many technologies that you even mentioned them that monitor blood sugar, and I'm sure that you could titrate an appropriate dose based on blood sugar levels. So
Yeah, but yeah, so like all of these we have, they involve like through skin penetration, and there may be some type of patients who are not comfortable with that. So if you were to use an inhaler and similar to an asthma inhaler, this would mean that it's more comfortable. And asthma is also, as I said, repeated before, that the one of the most widely recognizable disease and like most common affected. So then most people would be able to learn how to administer and use the inhaler.
Okay, thank you very much. A very, pertinent disease to be attacking at this point, right?
Yeah.
Okay, so I think we'll move on now to our last presentation, which is Sylvie Yao from Dwight Englewood High School in Englewood, New Jersey. The topic of her research is the effects of knowledge of the Monte Carlo tree algorithm and one's ability to do quick math on backgammon. What did I just say?
Yeah, hi. Can you see my screen? Yeah, okay. So, I'm Sylvie, and this is my project. So, the effects of knowledge of the Monte Carlo tree search algorithm and one's ability to do quick math on backgammon. So, I wanted to know whether humans could understand the Monte Carlo tree search algorithm, and if humans had a better chance of understanding it with quicker math skills. So, backgammon is a common game played where AI is used to create opponents for real players. The backgammon online site I used for this experiment uses the Monte Carlo tree search algorithm, in other words, MCTS. MCTS is a popular algorithm used for decision making and is often used in chess, poker, and Go. MCTS can also be used in backgammon, however, it isn't as popular. So I wanted to see how knowing MCTS affected someone's ability to play backgammon. The AI that plays backgammon against the participants is already trained to know MCTS, but humans aren't automatically given that knowledge, so they have to learn it. MCTS is an extremely hard algorithm to learn because for each move you make in backgammon, a whole new tree containing all the probabilities of what could happen is made. It is impossible for a human to use MCTS quick enough, but it is possible that a human can create the beginning part of the tree, which is still very helpful. So my hypothesis is knowledge of the MCTS algorithm and a better ability to do quick math in one's head creates a better outcome when playing backgammon. So I decided I would test both people's quick math skills and how well they played backgammon with and without knowledge of the Monte Carlo tree search during this experiment. The participants will be middle school students to adults. They will be told they are participating in a study on math games, but will not be told hypothesis. First, I tested all the applicants with 50 math flashcards containing addition, subtraction, multiplication, and division, with numbers ranging from 1 to 12. Based on the results, the participants will be sorted into two groups. Group 1, participants slow at math, which had a time of 30 seconds to 1 minute and 15 seconds. And Group 2, participants faster at math with a time of 1 minute and 16 seconds to 1 minute and 55 seconds. Next, participants in each of the two math groups will be randomly assigned to either the control group or the experimental group. All participants will watch a video on backgammon and play two games against a computer. Next, the experimental group will watch a video on the MCTS algorithm, while the control group will watch a video on Sudoku. Lastly, all the participants will play 2 games of backgammon against the same computer. With the data of wins and losses of all the participants, I will see if there's an improvement of backgammon skills against After watching the MCTS, and if there's an improvement, I will check the data to see if the group of people with quicker math skills and who watched the MCTS video are better at backgammon than those with slower math skills who also watched the MCTS video. I will compare these results to the results in the control group. After collecting all this data, I will see if being better at math and knowing the Monte Carlo tree search algorithm helps someone win a backgammon game. So these are my results. The experimental group, the participants that watched video about MCTS, had a 147% increase in wins after watching the MCTS video, where I used a t-test, which showed that my calculation was statistically significant. And while the control group, the participants that watched the video about Sudoku, had no significant improvement. The subgroups of those with quick math skills out of those who watched the MCTS video had a 200% increase in numbers of wins, which was also proven to be statistically significant through the t-test. So I found that knowing the MCTS and having quick math skills gives someone the best outcome when playing backgammon. When analyzing my data, I use a t-test which calculates whether my data is statistically significant. I needed to use this in order to see whether my data meant anything or if my data was just due to chance. I also use percent change to compare the percent change of the wins of the group that watched the MCTS video and those who watched the Sudoku video. I saw that those who watched the Sudoku video didn't have much improvement. Their improvement was by repeating the game, but not by trying to learn ways to get better at the game. Those who watched the MCTS video had a very visible improvement, with sometimes losing the first two backgammon games and then winning the third and fourth backgammon games after watching the video. Since I did not tell the participants to use what they had learned from the video in their next two backgammon games, I think the participants who watched the MCTS video subconsciously applied it to their gameplay, giving them a much better chance at beating the AI. So my conclusions are that my data supports my hypothesis that a combination of math skills and knowledge that MCTS increases success against a computer, AI, and backgammon. My hypothesis was supported because participants who watched the video on the Monte Carlo tree search algorithm had a statistically significant percent change of 147% in the backgammon games they won, while the control group did not have a significant increase. Those in the experimental group who scored well on the mental math pretest had an even higher percent change of 200% in backgammon wins after watching the MCTS videos, suggesting an interaction between baseline mental math skills and learning the algorithm. A limitation is that the sample size of 27 participants is smaller than I had expected, and smaller sample sizes are more likely to be affected by random chance. In my original experiment, I had the participants do two separate parts on 2 different days. This led many of the possible participants to not want to do the experiment because it was a large time commitment. I also had my experiment on a Google Doc with steps to do. This doc lost me many possible participants because it looked like more work than it was. So I changed my experiment to be done easily on a Google Doc, which gives you a step-by-step on what to do as you go along the experiment. This helped my participants not feel overwhelmed by too many instructions and made it easier for them to understand the instructions. So the next steps would be to keep exploring the idea that humans and AI can both understand the same concepts and ideas. I would like to continue this idea, but with different things, things possibly seen more in someone's everyday life. I think if I kept exploring this topic, I would unlock a lot of revolutionizing discoveries about AI and how it could help and not hurt the world. Okay. So my project finds that humans can comprehend the same things as AI, which challenges the current idea that AI learns and grows from humans. I think this idea isn't seen as much as it should be because people are often held up by the fact that AI is too powerful and will take over society. AI is such a fast-growing industry and is very important to better understand how humans can control it. This will help the whole world because as the world changes, ideas need to change with it. As AI advances, we must learn how humans can benefit from it. My project shows that AI only seems to be more intelligent because of its ability to make quick decisions and calculations. I also show how humans can lessen the gap of intellect between humans and AI. So contributions. All my research was done at school. My mentor helped me find the best ways to reach out to people so I could get the most possible participants. My mentor suggested the way to participate in my experiment was to complete and submit a Google form. The Google form helped me make 4 distinct groups and made it easy for me to collect all the information in one place. My mentor played a big role in helping me during my project. She helped me collect information and taught me the best way to analyze my information. I would also like to thank my friends and family for helping me get as many participants as I did. When I felt that I didn't have enough data, my friends and family reached out to as many people as they could to help me get more participants in my data. I would also like to thank all the participants who were part of my experiment. My experiment ended up being longer to do than I expected, and I'm really grateful to all the participants who stuck through it and finished the Google form. Even though this was an individual project, it was the farthest away from a solitary activity. Thank you.
Very nice. Questions? I have a question. Sudoku, like why you chose Sudoku as your
Yeah, so the Sudoku video was to be seen as something that wasn't gonna end up helping them in the end. It was just sort of so that there was a like the Sudoku video and the MCTS video were meant to be the same length. So there was a specific time in between two sets of backgammon games they played. So
because
it's
I
just
think of
supposed-
Sudoku, I think of math.
yeah, yeah, it was just supposed to be like wasting time.
Okay, thank you. Sophia.
I was wondering what inspired you to do this specific project.
Yeah, so like I'm really into board games, and so I did this project for the Bergen Sci Challenge. So right before I was trying to figure out what to present, and then I found this backgammon set that my uncle bought me like a few years back. And then I was like, "Oh, this is such a good idea." And then like I obviously just can't just be talking about backgammon the whole time. So then I found the Monte Carlo tree search algorithm to talk about, and I saw that the Monte Carlo tree search algorithm could be applied to backgammon. So that's when like the idea sprung. So yeah.
So how long is the MCTS video, like algorithm video?
Well, I didn't want it to be too long, so I took a part from like other video. So the part that the participants watched was about like 6 minutes.
Just
But
6
it was like
minutes?
very, very like intense math equations and like there's a lot going on.
Oh. So that 6 minutes gave this much improvement in their math ability?
Yeah, it was.
Oh.
Yeah, it was.
That's cool. Good to
Yeah.
know.
Interesting, right?
Yeah.
Other questions? I would like to actually also appreciate these students who, mentioned limitations to their study, acknowledgments of those who helped them. And, those are important things that, in the future that, think about it. Because it's important to realize the limitations. And, but everyone did such an extraordinary job. It was just wonderful. Kiruthika, do you have anything you'd like to add?
I really enjoyed this evening hearing so many presentations and different aspects, how they get these kind of different ideas. Like it's so unique. Each and every project is so unique. I'm so happy that you people presented here in New Jersey Academy of Science. We would love to have you in our annual meeting also. It is on April 20th in Keene University. You can go to our website and you can find more details. Please do come over there. We have 140, around 50 presentations from Junior Academy, that is high school students. So we would love to have you all there. And Jonah, do you want to explain them? They'll get the free membership and certificate.
Yeah, so we're the New Jersey, or is Maria, are you here? Would you like to comment or?
Sure. Hi all. I am so delighted to, and I learned so much today from you guys. It was an amazing day and evening to share this with you, share the knowledge of how the young scientists can produce in our New Jersey community. This initiative of life that you took the time tonight, it's a very rewarding time because we will, as part of our new cohort or 2024 cohort, you have or will be receiving your New Jersey Academy of Science free membership for this year, 2024. Now, with this, it entitles you to actually go to any of our events. Now, our event, for example, the annual meeting, you could attend. In that day, we will have all the Junior Academy presenters, that's the high school, and we'll have the Senior Academy, which encompasses all the students who are undergraduates, graduates, and faculty members. So you are welcome to join us. You are invited. We will be sending you a link to register. And I highly recommend, I think all these presentations, you have so much great ideas, and I think you could take it to the next level. We will have people there for you to network with and actually get interchange ideas with them, whether it's your peer or professors or people in the industry. It is going to be a great event. Not only will there be the junior and the senior academy presentations, but we will have what we call is seminar sessions for different levels and see how can you get involved and help out your community. And I hope I can see you there personally. I'm looking forward for many of you. I already have the faces that I've seen you. And please know that this video will be put in the New Jersey Academy of Science website. So if you forgot or you're wondering, you're nervous today, you're wondering how you did, definitely you could rewatch this video at your best convenience or share it with your families. Thank you so much for all that you do to make New Jersey a scientific community that is well educated and up to date with the things that we should be knowing. I'm very impressed with our youth and how you are contributing to our community. Thank you so much.
Thank you, and we wish you all a wonderful weekend.
Thank you.
Bye-bye.
Thank you.
Thank you.
Thank you.
Thank you.
You're welcome. We have a question. Aditya, go ahead.
Yes, I'm actually going to be there at the the annual presentation. I'm going to be a
Nice.
participant.
I'm looking forward to see you then.